Hi, let's now try to understand little more about the 8-stage voltage multiplier circuit. What we had seen in the last video about the functioning, we will go into the how the circuit really works. Now, for example, if this is my supply voltage and my supply voltage is, we have taken deliberately about the 300 volt because that will be indicating the peak voltage as compared to the RMS voltage normally that we see in our multimeters or in a voltmeter. So let's see how it works. Now when the supply, say if this side is positive in the one half cycle, this side is positive and this side is negative, so what happens, the positive supply would start this way, this will forward bias this diode and it go this ways and then starts this, charging the capacitor and comes back to the source. So it starts from the positive, goes this way, charges the capacitor a positive and reaches here. All this happens in the one half cycle. And in the next half cycle, what happens when the supply reverses, that means this becomes negative and this becomes positive. So what happens, what we find, now this was already charged to the voltage of V, supposing this is V, it has already charged to the V, and now this side is positive, this side is negative. In the other half cycle we found that this is positive, this is negative. So what happens, positive, negative, they get added, and between this point to this point it becomes V plus V. So between this point to this point it is 2V. And since this is 2V between these 2 points, so this positive now travels here and then this diode gets forward biased and it flows this way, and this is charged to 2V because this 2V was available here and this 2V is now coming and getting charged here and charging this capacitor to 2V, because between here and here what we found, 2V was available and that 2V was charged the capacitors, this to 2V. And again on the next half cycle, this becomes positive, this becomes a negative. So whatever 2V was available here is now added with this voltage, that is positive, negative, and with respect to this point becomes 3V, because 2V plus V is 3V. So that 3V is now charged. Now this capacitor charges to 3V this way. So and so on. It goes on to, this goes to 4 kV, this goes to 4V, this goes to 5V, this goes to 6V and 7V and 8V. This is how it works. And mind it, this capacitor gets charged to the peak of the voltage and not the RMS voltage what we normally know. And then coming to the load versus the pulsating voltage, we will also see that and what happens when we load the circuit. Now let's, for example, we now try to simulate this. And what we find is that if the load is not connected, supposing the load, I remove the load. Now supposing I remove the load is not connected, what we find that in the zero range, this is the zero range, that I have kept the CRO in the AC range, not in the DC range. I kept the CRO in AC range to see the pulsating voltage, and let me keep this at say 1 volt scale, and since I have kept it in 1 volt scale and it is not loaded, because the loading earlier, if you look at the loading is only these series resistors of 1 megohm each, about 10 megohm. So it's a very negligible load because the resistance is 10 megohms, whereas if this is a 100k load, if I switch on this now, what happens, we will see that when this 100k load is switched on, what you can see is that, see, from this point what we found that from this point the voltage is roughly going to in every, this is also in the 5 millis, the scale is in the 5 millisecond range, and we can expand this also so that you can see in the 2 millisecond range, and that means if each division is 2 millisecond, what we know, that means from here to here is 1, 2, 3, 4, 5 or 10 milliseconds. So for what happens, what we can now see, this capacitor charges from here to here and then discharges, and then again discharges and then again charges, and that is how the operation. Now let's go to the scale again, back again. Now if I bring it to the off, if I bring it to the ground, let us see where the ground is. Now ground is here, this plane. Okay, to get a reference, now in this line the ground is. Okay, now if I take it to the AC range, when I take it to the AC range, what we found is that the pulsating DC is, this is the place where the voltage is, the ripple voltage is rising to this and then falling and then going this way, and this. But as far as the DC is concerned, we can only see it when we take into 20 volt range, because the supply voltage what we have taken is about 200 volts. Now supposing I take it to in the 20 volt scale, and I take it to the DC range. If I take it to the DC range, what we find, okay, now this was my zero line, this was my zero line, and so what is the voltage now? How many divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9, or maybe this is the range now. Okay, 1, 2, 3, 4, 5, 6, 7, 8, or 9. 9 means 20 into 9 is about 180 volts. That is what when we load this. When we do not load it, like for example, when I do not load this, now when I do not load this, I find the voltage is nearly in this range. How many divisions? If this was the 0 here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, a point something, so nearly about 10. So 20 to 10 is about 200 volts that I'll be getting if I load this to this, and it is showing 237 volts as far as the meter is concerned. So when it is not loaded, we find that the voltage is pure DC, and but when it is not loaded, the voltage is pure DC. When it is loaded, we find there is a slight pulsating DC, and the average DC falls, and there is a pulsating DC also above the certain voltage. In any case, from here to here is DC, but the DC has pulsating range. To see the exact pulsating range, so we can take it to the AC scale, and we find that in the AC scale we are able to read. Now supposing I take it to the 1 volt scale, I find this will be the pulsating voltage over the voltage that we had seen. Now how it happens? Let's see how it happens. That is very common as far as any situation is concerned.